Ladies and gentlemen.
Yes.
Today I'm very excited to be here to present to you our research proposal. This proposal is part of the R&D program Optimization of Water Resources for Hydrothermal Power System. The title of the proposal research project in this program is Modeling of a Sungai Perak Cascaded Hydro System in Texas Integrated Energy Model software. Let me first describe the situation. Currently, the single buyer department, our scheduler, uses Texas Integrated Energy Model software to determine the hydrothermal mix for weekly to daily generation scheduling. And they approximate the available water from hydro resources by defining the energy constraint in the software, which is only for the generator, the maximum energy, the minimum energy, and the maximum capacity. Using this approach, the schedulers are treating the hydro resources as thermal resources, which means there's no limit to the hydro resources. You can just purchase as long as you have money. The problem with this is when hydro resources are treated as a fossil fuel is the schedulers are not able to capture the stochastic behavior of natural flows. So the random flood and also drought cannot be captured in the schedules. They are not able to capture the constraint in terms of water storage in them. They are also not able to model the interdependency between the storages, especially for those cascaded systems like Sungai Perak, when you have one reservoir after another.
This results in an increase in fuel cost.
This results in the hydro resources not being optimized, and the random flood and drought events are not being able to capture. In detail, the schedulers are not able to provide the optimal strategy to operate to increase and to maximize the opportunity cost of hydro operations. So we do not know how much water should release. When should they release? Should they drain it too low? Because if you're draining it too low, it may actually cause a generation shortfall and cause you to actually generate more from the thermal. Or if they keep it too high, it may cause the opportunity cost, loss of opportunity cost because of sudden spillage. Okay. But there is opportunity to prove this and this can be done by accurately approximate the water resources for scheduling by modeling the hydro resources in Texas through the waterway, storage, and generator class.
No, actually, for that one, for the position, what you should have said is there is an opportunity. There is an opportunity to optimize.
Actually, there is an opportunity to optimize the use of that Flexor software, and we can do it by modeling the hydro resources in the software through the waterway, storage, and
let me correct the sentence there. There is an opportunity to optimize the use of hydro power, water power. I'm just saying this there. Using the Plexos software, something like that. Optimize what?
Want to optimize the use of that software. Because currently they are using it just for the energy part, energy constraint. They are just defining the constraint. So basically, they are not defining.
Okay. So say that in words. There is an opportunity to optimize the use of.
There is an opportunity to optimize the use of the Plexor software for improving the hydro generation.
There is an opportunity to reduce the cost of thermal power.
There is an opportunity to minimize the system cost.
Okay, so
to minimize the system cost by using the better use of the Plexor software And this can be done by modeling the hydro resources in the PlexSource software,
which is currently
not
being done.
In specific, we would like to apply this to the cascaded hydropower system of Sungai Perak, which consists of Temenggong, Bersia, Kenering, and Cenderum.
Okay.
What we need to do is to configure those classes, waterway storages, and so on. We need to configure the inflow for Temenggong, Bersia, Kenering, and Cenderum. We need to do installation of and commissioning of the gauging station site.
Louder, you don't sound excited. Louder, sorry.
To configure.
Yeah. So the action.
To configure the PlexSource software, we basically need to do a lot.
Ah.
I need the word.
Okay, let me help you. You see, the way you have put it, to configure inflow, meaning you already have the parameters in mind. But are you, or is this proposal to investigate and discover the right parameter setting?
The right parameter setting.
Huh?
Right parameter setting.
To investigate it.
To find out.
Yeah. So that means the action is to investigate and discover the right parameter setting to configure the inflow for the 4 dams. So because you say to configure, meaning you already have it, you just go and configure only. So that's not research.
It's not there yet.
But the action is the research, is it? So
the action is to investigate the parameter settings of inflow for Temenggong, Bersia, Kenering, and Cenderum, which can be done by installation and commissioning of gauging station, site measurements, and data collection, and also
to investigate
the traverse time, the relationship between the traverse time and inflow for the
so that the traverse time as a function of inflow can be correctly configured. Yalah.
I think yours also a bit. It's okay.
Yeah, but the keyword here is to investigate and discover, because you don't have the right configuration yet, have you?
No.
See?
We have to do experiment.
To experiment, to investigate. So that is the action. So can you go through this slide again in your own words, but use the word investigate?
So the action is to investigate the configuration, the parameter settings for inflow of Temenggong, Bersia, Kenering, and Cenderum.
Yes,
and
correct.
This can be done by the installation and commissioning of gauging stations, site measurements, and the data collection. We also need to investigate the function between traverse time and inflow between the reservoir, between Temenggong and Bersia, Bersia and Kenering,
good.
and Cenderum.
Good.
There are 2 approaches for this, and we also need to
investigate.
Investigate the configuration, the functions between the spillage and weir elevation, and also the spillage versus gate opening equation. Besides, we also need to conduct relative efficiency tests to determine the efficiency for Temenggong, Bersia, Kenering, and Cenderum. Finally, besides determining all these parameter settings for the schedulers, we also need to develop a customizable software for cascade control optimization for the operators, because without all this, whatever has been scheduled cannot be implemented accurately. Fine. This one I will finish. So at the end of the day, we expect by doing this we can minimize the system cost by, for example, 10 million. And at the same time, this can be done by while satisfying the system constraint. That's all. Thank you very much. No questions?